The expanse of the cosmos reveals itself as a meticulously rendered landscape, a theatre of light and shadow stretching across billions of years of silent evolution. For centuries, the human mind approached this vastness with a singular conviction that the universe is governed by an underlying logic, a set of immutable instructions that dictate the behaviour of every particle, from the smallest grain of stardust to the most massive supercluster of galaxies. These instructions, which we have named the laws of physics, were long perceived as the foundational source code of reality, a series of absolute commands that ensure the stability of the cosmic engine. In this era of classical certainty, the heavens appeared as a grand, predictable clockwork mechanism, functioning with a precision that suggested a finished and polished design. The pioneers of science looked upon the night sky not as a chaotic void, but as a completed blueprint, a masterpiece of celestial engineering where every cog and gear moved in perfect harmony. During the 17th and 18th centuries, the realization dawned that the movements of the planets were not the result of divine whims or erratic spirits, but were instead the consequence of a singular, elegant operating system. This was the age of the clockwork universe, a time when the rules of the game seemed fixed, and the engine of creation appeared to run on a track of absolute determinism. It was believed that if one could possess the coordinates and the velocities of every atom in existence, the entire future of the universe could be calculated with the same certainty as a mathematician solving a simple addition. Central to this understanding was the concept of the vacuum. Space was envisioned as a stable stage, a neutral background against which the drama of matter unfolded. This void was not a temperamental or shifting entity, but a consistent medium, a reliable substrate that obeyed the ultimate instructions of motion. Within this silent theatre, the primary force was gravity, the invisible thread that wove the tapestry of the stars together. It was gravity that commanded the Earth to circle the Sun and the Moon to dance around the Earth, following paths so predictable they could be mapped centuries in advance. The inverse square law functioned as a hard-coded constant, a rule that ensured the influence of mass would fade with distance, in a manner that was both beautiful and mathematically perfect. This predictability gave rise to a profound sense of architectural confidence. Astronomers and physicists walked through the halls of science with the spirit of explorers who had finally understood the mind of the architect. They saw the cosmos as a system of default settings, a universe where an object in motion would stay in motion, drifting through the vacuum in a state of force-free grace unless acted upon by an external hand. This was the steady state of our understanding, a world where the rendering of reality was smooth and the frame rate of existence was constant. We grew comfortable in the belief that the engine was stable, that the vacuum was a passive container, and that the laws of motion were the final word on how the story of the universe would be told. As the centuries progressed, this confidence only deepened. The discovery of new planets like Neptune, found not by chance but by the mathematical ripples its gravity sent through the orbits of its neighbours, seemed to confirm that the source code was fully understood. The universe was a solved puzzle, a machine whose every output could be traced back to a specific input. The vacuum was thought to be empty of surprises, a quiet void where light travelled at a constant speed and time flowed like a steady river. We mapped the stars with the same precision that a cartographer maps a city, believing that the boundaries of our knowledge were expanding to fill a territory that was fundamentally logical and eternally fixed. In this classical rendering, the vacuum of space served as the ultimate floor of reality, a zero point where nothing happened unless a force was applied. This concept of force-free motion became the cornerstone of our physical reality. It suggested a universe of perfect conservation, where energy and momentum were passed between objects like currency in a closed economy. There were no leaks in the system, no hidden variables, and no glitches in the matrix. Every star that drifted through the dark was seen as a testament to the reliability of the engine. The cosmos was a grand simulation that had been running for billions of years without a single crash or error, and we were the inhabitants who had finally learned to read the underlying script. We looked at the spiral arms of distant galaxies and saw them as majestic displays of these same simple rules, scaled up to a terrifying magnitude. We believed that from the fall of an apple to the collision of two suns, the same lines of code were being executed. This was the comfort of the classical era, the belief that the universe was a house built for reason, a structure whose foundations were laid in the bedrock of absolute law. We stood on our small blue world looking out at the vastness and felt a sense of mastery. The blueprint was in our hands, the gears were in motion, and the engine of the cosmos hummed with the quiet rhythmic sound of a machine that would never break, never falter, and never change its mind. Yet this architecture of certainty rested on a single unspoken assumption: that the rules we observed in our small corner of the rendering were the same rules that governed the entire system. We assumed the vacuum was truly a blank slate, and that the laws of motion were universal constants that remained unchanged across the infinite reaches of space and time. We had spent hundreds of years perfecting our map of the local neighbourhood, never suspecting that the further we looked into the distance, the more the rendering might begin to fray at the edges. We were like players in a vast game who had mastered the first few levels, never imagining that the physics engine itself might be programmed to behave differently once we reached the outer limits of the map. The era of classical certainty was a golden age of understanding, but it was also a time of profound innocence, a period before the first flickers of the dark accelerations began to suggest that the source code of reality was far more complex and far more alien than we had ever dared to dream. Into this atmosphere of growing suspicion arrived a diagnostic tool of unparalleled sophistication, a project designed to peer through the very grain of the cosmic rendering. This was the three-dimensional infrared atlas, known in the quiet laboratories of the world as the 3-eye atlas. It was not merely another telescope, but a high-fidelity scanner, a system intended to perform a deep-layer audit of the local universe. While previous generations of astronomers had been limited by the visible spectrum, the narrow band of light that the human eye can perceive, the 3-eye atlas operated in the infrared. This choice was deliberate and transformative. Visible light is easily scattered and blocked by the immense clouds of cosmic dust that permeate the spiral arms of galaxies, acting like a thick fog that blurs the movements of the stars behind it. Infrared light, however, possesses a longer wavelength, allowing it to slip through these obstacles and carry its message across the void. The sensors of the 3-eye atlas functioned as cold, unblinking eyes, chilled by liquid helium to temperatures hovering just above absolute zero. This extreme cooling was necessary to ensure that the heat from the instruments themselves did not drown out the faint, ancient whispers of distant starlight. From their vantage point, these sensors looked out into the dark with a terrifying clarity, piercing through the soot and gas of the Milky Way to observe the true positions and movements of thousands of nearby galaxies. Each galaxy was no longer a smudge of light on a photographic plate, but a distinct entity with a measurable velocity, a specific coordinate in the three-dimensional grid of the local volume. The process of data collection was akin to a sudden and dramatic increase in the simulation's resolution. Where once our maps of the heavens were like impressionistic sketches, the 3-eye atlas began to fill in the pixels, revealing the fine-grained structure of the cosmic web. It measured the velocities of these stellar islands with a precision that was previously impossible, tracking how they drifted through the sea of space-time. This was the moment the resolution of our reality was turned up, and as the image sharpened, the movement of matter began to reveal a story that did not align with the established models. The researchers were no longer looking at a low-fidelity approximation of the universe. They were staring at the raw, undeniable feedback of the physics engine itself. In the old models, the motion of a galaxy was dictated by a simple ledger of mass and gravity. You counted the stars, you estimated the gas, you added the hypothetical halo of dark matter, and the resulting gravitational pull told you exactly how fast that galaxy should be moving. The 3-eye atlas, however, began to provide data that refused to balance the books. As the infrared light was decoded, It revealed that galaxies were not merely drifting according to the sum of their parts. Instead, the survey captured thousands of individual data points, showing that these objects were moving with a strange, uncoordinated energy. It was as if the pixels of the simulation were being shifted by a force that had not been accounted for in the original source code. This transition from theoretical expectation to empirical reality was jarring. The 3i Atlas was not finding subtle errors. It was uncovering a fundamental discrepancy in the cosmic ledger. The velocities of dwarf galaxies and the outer shells of larger systems were higher than the total mass of the visible and dark matter should allow. To the scientists analysing the data streams, it felt as though they were watching a high-definition playback of a machine that was malfunctioning in plain sight. The infrared eyes of the Atlas had stripped away the veil of dust and revealed a universe that was far more active and far less predictable than the architects of classical physics had ever promised. The resolution of this new map was so high that it allowed for the isolation of specific gravitational environments. Astronomers could now look at regions of space where the gravitational pull from neighbouring mass was effectively zero, the true force-free zones of the cosmos. According to every law written since the time of Newton, an object in such a zone should move at a constant, unchanging speed. Yet, the 3i Atlas showed these objects were accelerating. They were gaining speed in the middle of nowhere, pushed by a ghost in the machine. This was the raw feedback that changed everything. The infrared data was not just a collection of numbers, it was a signal that the simulation was rendering motion where there should be none. As the thousands of data points were plotted onto the three-dimensional grid, a pattern began to emerge that defied the standard model of cosmology. The default settings of the universe, the rules that governed how matter should coast through the vacuum, were being overridden. The 3i Atlas had performed a diagnostic on the very fabric of space and found that the vacuum was not a passive stage. It was as if the diagnostic tool had uncovered a hidden routine in the code, a background process that was kicking the galaxies and star clusters, giving them a velocity that came from outside the known gravitational framework. The arrival of this data marked the end of the era of architectural confidence. The blueprint was no longer a reliable guide to the building. The infrared sensors had provided a window into the deep layers of the rendering, and what they saw was a glitch that could not be ignored. The ledger of the heavens was broken, and the discrepancy was growing with every new galaxy the Atlas mapped. The universe was revealing itself to be a system where the rules of motion could be edited on the fly, and the 3i Atlas was the witness to this silent revolution in the source code. The stage was now set for a confrontation between the laws we thought we knew and the reality that the infrared light had so coldly and clearly revealed. At the heart of the cosmic engine lies a single, elegant logic gate, a fundamental command that has served as the bedrock of our physical reality for over 3 centuries. This is the principle of force-free motion, the primary instruction in the universe's source code, which dictates that an object will persist in its state of rest or uniform motion unless compelled to change by an external influence. In the grand architecture of the simulation, this law functions as the ultimate if-then statement. If the sum of all external forces acting upon a body is zero, then its acceleration must also be zero. For generations, this was not merely a theory. It was the definition of the vacuum itself, the baseline of existence that allowed us to believe in a rational and predictable world. To understand the weight of the discovery made by the infrared sensors, one must first look at the deep reaches of the intergalactic void, far from the violent tug of massive suns or the dense gravitational wells of galactic cores. In these lonely stretches of space, where the distance between matter is measured in millions of light years, the influence of gravity should fade to a mere whisper. Here, a galaxy or a stray star cluster is expected to exist in a state of pure, unadulterated drift. It carries with it only the ghost of its initial momentum, a legacy of the titanic forces that birthed it during the dawn of time. This momentum is a memory of the past, a silent energy that should propel the object through the darkness at a constant, unchanging speed forever. This envisioned motion is a silent, frictionless glide, a journey through a medium that offers no resistance and demands no tribute. In the classical rendering of the universe, the vacuum is the perfect stage for this display of inertia. Without the friction of an atmosphere or the constant pulling of nearby mass, the trajectory of a celestial body should be as straight and true as a line drawn on a geometric plane. This is the default setting of the cosmic engine, the state of grace where the laws of motion are observed in their most pristine form. We have long relied on this predictability to navigate the stars, using the constancy of force-free motion as a compass to orient our understanding of the deep dark. The expectation was clear. In the absence of a visible pusher, be it a nearby galaxy, a dark matter halo, or a local concentration of energy, there should be no change in velocity. The speedometer of a drifting galaxy should remain frozen, its needle locked in place by the absolute command of the first law. This constancy is what makes the universe a solvable system. It ensures that the past predicts the future, and that the same rules apply in the empty spaces as they do in the crowded ones. This force-free state was intended to be the control group of the cosmic experiment, the standard against which all other interactions were measured. However, the reality of the void, as revealed by the sharp eyes of the latest surveys, has begun to diverge from this idealized blueprint. The baseline is shifting. When we look at the farthest reaches of galactic systems, where the gravitational pull of the center should be failing and the motion should be transitioning into a steady, force-free coast, we instead find a surge of energy. Objects are not merely drifting, they're accelerating. They're gaining speed in the middle of a gravitational wasteland, behaving as if they are being propelled by a hidden engine or caught in a ghostly wind that no instrument can detect. This deviation is not a minor error in calculation. It is a profound edit to the laws of motion themselves. If an object accelerates without a force, the logic gate of the universe has been bypassed. It is as if the simulation has decided to change the rules of the game in the middle of a session, allowing for an output that has no corresponding input. To find acceleration in a force-free environment is to witness a breakdown of the very causality that defines our world. It suggests that the vacuum is not a passive stage, but an active participant in the rendering, capable of exerting a push that is not accounted for in any of our traditional equations. The imagery of a silent, frictionless drift was our comfort, a sign that we understood the fundamental mechanics of the machine. We saw the universe as a place where motion was a legacy, not a mystery. But if the ghost of initial momentum is being overridden by a new, dark acceleration, then the legacy is being rewritten. The force-free state, once the most stable and reliable aspect of our physics, has become the site of a celestial rebellion. Every meter per second of unexpected speed is a line of code that we did not write and cannot explain. As we move deeper into the data provided by the infrared atlas, this baseline of inertia serves as the ultimate yardstick for our ignorance. We measure the anomaly by how far it strays from the silent drift we expected to see. The contrast between the expected behavior of a coasting galaxy and the observed reality of its sudden sprint is the gap where our current understanding of physics falls into the abyss. We are forced to confront the possibility that the operating system of the universe is far more dynamic than we imagined, possessing hidden routines that can kick a galaxy into a higher gear even when the ledger of forces says it should be standing still. This is the first true glimpse of the glitch, a moment where the smooth rendering of the cosmos stutters and the underlying architecture of the simulation begins to show through the cracks. The transition occurred during the threshold of 2023 and 2024. Digital streams, once orderly and compliant, began to pulse with a strange dissonant energy across the monitors of research institutions worldwide. Data harvested from the Herschel Space Observatory, which captured the cold, long-wavelength glow of cosmic dust, was overlaid with the precise optical mapping of the VST, the VLT Survey Telescope. This union of infrared and visible light was intended to finalize the inventory of the local universe, to count every sun and weigh every cloud of gas with definitive accuracy. Instead, it revealed a fracture in the rendering of reality, a moment where the high-definition image of the cosmos began to stutter. Researchers sat before glowing screens that displayed the velocities of dwarf galaxies and the sprawling thin shells of distant star clusters. These are the quiet suburbs of the cosmic city, regions where the gravitational influence of massive structures is at its most diluted, and where the rules of motion should be at their most transparent. But as the algorithms processed the information, a flicker appeared in the data. The speed of these objects was not merely high, it was defiant. The motion of these distant islands of light refused to align with the mass that was present. In the fundamental ledger of the cosmos, the assets, the stars, the gas, and even the theoretical halos of dark matter did not equal the expenditures of kinetic energy being observed. These data points emerged as rebel signals, screaming from the depths of the datasets like alarms in a silent room. They were orphans of the standard model, particles of information that refused to be tucked away into the neat boxes of the established cosmological framework. Every time a scientist checked the calculations, the discrepancy remained, stubborn and cold. The galaxies were moving as if they were being pulled by a phantom moon or pushed by a silent, invisible tide, yet the surrounding space was empty of any such influence. The established gravity models, which had served as the gold standard for a century, began to buckle under the weight of this new, raw evidence. The investigation quickly took on the atmosphere of a detective story, where the crime scene itself was in a state of constant, impossible flux. The investigators, the cosmologists and astrophysicists who had spent their lives studying the clockwork of the heavens, realized that the fingerprints left by gravity were not matching the suspects on the table. They looked for hidden mass, for unobserved clouds of molecular gas, or for any mundane explanation that would preserve the sanctity of the textbook. They searched for errors in the instruments, for calibration offsets, or for a simple misinterpretation of the light. But the more they scrutinized the evidence, the more they realized that the crime was not a missing piece of matter, but a change in the rules of the game itself. The fabric of space-time was telling a story that had never been written in any manual of physics. It was a moment of profound realization. The rendering was failing to match the theory. The smooth, predictable motion of the heavens was being interrupted by a glitch that suggested the engine was operating under a different set of instructions than the ones we had studied for generations. The VST data showed the positions of these stars with absolute crystalline clarity, while the Herschel data confirmed the lack of any obscuring mass that could account for the extra pull. Together they formed a pincer movement that trapped the standard model in a corner. The acceleration was real, it was measurable, and it was entirely impossible according to the laws of Newton and Einstein that govern the world we thought we knew. The researchers watched as the rebel signals multiplied with every new scan. 1 galaxy, then 10, then 100, all showing the same impossible surge in speed. It was as if a ghostly hand was reaching into the simulation and flicking the galaxies like marbles across a glass floor, giving them a burst of velocity that should not exist in a balanced system. The crime scene was no longer a static location to be analysed. It was a dynamic, shifting environment where the very laws of nature were being edited in real time. The textbook spoke of a universe governed by the distribution of mass, but the data spoke of a universe governed by something else, a dark acceleration that operated independently of the matter it was moving. This was the transition from academic curiosity to a full-scale crisis of understanding. The flicker in the rendering was not a temporary error or a flaw in the lens. It was a fundamental revelation of a deeper, more chaotic layer of the source code. The investigators were forced to confront the terrifying idea that the source code was not as fixed as they had believed, and that the vacuum itself might possess a hidden agenda. The data streams of 2023 and 2024 became the permanent record of this awakening, a digital testament to the moment humanity realized that the cosmic engine was running on a logic we had yet to even name. The story written in the stars was changing, and the old language of physics was no longer enough to read the new chapters being written in the dark. In the quiet outskirts of the cosmic architecture, the small and the fragile have begun to scream in defiance of the law. These are the dwarf galaxies, tiny clusters of stars that huddle together in the vast emptiness between the great spiral leviathans and the thin, ghostly shells of stars that linger at the extreme edges of galactic clusters. In the traditional hierarchy of the heavens, these peripheral systems are the underdogs, the low-mass participants in a celestial race where they should, by all rights, be trailing behind. Far from the dense gravitational anchors of the cosmic urban centres, where the pull of massive black holes and millions of suns dictates the pace of existence, these distant suburbs were expected to be realms of slow, predictable motion. But the data revealed a reality that contradicts every textbook ever written. These small peripheral systems are being kicked. It is not a physical impact, nor is it the result of a collision with another body of matter. Instead, it is a sudden, inexplicable surge in velocity, a dark acceleration that propels these tiny galaxies forward as if they were being pushed by a hidden hand. In regions of space where the gravitational field is so weak it should barely be measurable, these objects are accelerating where they should be slowing, or, at the very least, maintaining a steady coasting drift. It is a celestial race where the smallest, most insignificant participants are suddenly outstripping the heavyweights, moving at speeds that defy the combined weight of every visible star and every theoretical particle of dark matter in their vicinity. This phenomenon is not a global average or a uniform shift in the background of the universe. It is a localized anomaly that suggests the physics engine is behaving differently in the suburbs than it does in the dense city centres. In the heart of a massive galaxy, the sheer volume of matter creates a gravitational environment so intense that the standard laws appear to hold firm. There, the code is executed with the expected precision, and every orbit follows the path laid down by the mass of the system. But as one moves away from these crowded hubs, out into the thin air of the intergalactic countryside, the rules begin to fray. The dark accelerations act as a localized glitch, a specific routine in the source code that only triggers when the gravitational density drops below a certain threshold. The imagery is that of a machine that works perfectly under heavy load, but begins to malfunction as the task becomes lighter. In the deep void, where the influence of the inverse square law should render gravity almost irrelevant, these dwarf galaxies are experiencing a kick that should not exist. They are gaining kinetic energy from a vacuum that is supposed to be empty of such potential. This is the great contradiction. The less mass there is to guide the motion, the more the motion seems to depart from the guidance of mass. The suburbs of the cosmos have become a frontier of lawlessness, a place where the fundamental relationship between matter and movement has been severed. This localized nature of the anomaly points to a profound inconsistency in the rendering of our reality. It suggests that the laws of physics are not universal constants, that apply equally to every coordinate in the simulation, but are instead context-sensitive instructions. In the high-density regions, the engine operates on one set of rules, while in the low-density regions, a different, more mysterious set of parameters takes over. These dark accelerations are the signature of this transition, the moment the software of the universe switches from the classical gravity model to a darker, more alien logic. The scale of this discrepancy is staggering. When researchers measure the velocity of these dwarf galaxies, they find they are moving thousands of kilometers per hour faster than the visible and invisible mass should allow. If gravity were the only driver, these systems would need to be 10, 20, or even 50 times more massive than they appear to be. Even the most generous estimates of dark matter, that invisible scaffolding we invented to fix our broken equations, cannot account for these specific, localized bursts of speed. The kick is too sudden, too localized, and too powerful to be the result of a static halo of unseen particles. It is a dynamic event, a change in the state of motion that occurs in the absence of a cause. To see these small galaxies sprinting through the dark is to witness a breakdown of the causal chain. In our world, an acceleration requires a force, and a force requires a source. But in the outer shells of the galactic clusters, the source is missing. The dark accelerations are a result without a beginning, a movement without a mover. This realization transforms our understanding of the cosmic suburbs from a quiet graveyard of old stars into a laboratory of impossible physics. The small participants in the cosmic race are no longer just victims of the void. They are the messengers of a deeper truth, showing us that the default settings of the universe are not as stable as we believed. As the data from the three-dimensional infrared atlas continues to pour in, the map of these anomalies grows more detailed. We see that the kick is a consistent feature of the low-density landscape. It is as if the simulation has a flaw, a minimum level of activity that it maintains even when the matter count drops to zero. The dark accelerations are the visual evidence of this background pressure, a ghostly wind that only becomes apparent when the heavy anchors of gravity are removed. In the dense urban centres of the cosmos, we were blinded by the light of a million suns and the heavy hand of mass. But out here, in the cold, thin suburbs, we are finally seeing the true, unvarnished behaviour of the engine, and it is a sight that challenges the very foundation of our scientific identity. The standard framework of cosmology, known as lambda cold dark matter, has long stood as the definitive map of the heavens. It is a grand architectural edifice, constructed over decades of observation and mathematical labour, designed to explain how the universe expanded from a hot, dense point into the sprawling web of galaxies we see today. In this model, the cosmos is a delicate balance of three primary ingredients: ordinary matter, the mysterious dark energy that drives expansion, and the invisible scaffolding of dark matter that holds everything together. For a long time, this structure seemed unshakable, a perfect synthesis of the general theory of relativity and the observed distribution of stars. But under the relentless pressure of the latest data, this edifice has begun to crumble, its foundations cracking as the weight of new observations becomes too great for its ancient beams to support. The discovery of the dark accelerations acts as a sledgehammer swung against the very heart of this model. The central pillar of lambda cold dark matter is the idea that the extra gravity needed to explain the rotation of galaxies comes from a vast, unseen halo of cold, slow-moving particles. According to the theory, this dark matter is the silent master of the universe, outnumbering visible atoms by 5 to 1 and providing the gravitational glue that prevents galaxies from flying apart. However, the specific localized kicks observed in the dwarf galaxies and the outer shells of galactic clusters do not behave like the influence of a static cloud of particles. They are too sharp, too sudden, and occur in regions where the dark matter density should be far too low to produce such a dramatic effect. The situation has become a failing calculation, a mathematical nightmare where the books simply refuse to balance. For years, when astronomers found a galaxy moving too fast, they simply added more dark matter to the equation, adjusting the parameters to fit the observation. It was a process of constant refinement, a belief that the missing mass was just around the corner, waiting to be detected by our underground sensors or our orbiting telescopes. But the dark accelerations have broken this cycle of adjustment. No matter how much invisible mass is poured into the theoretical models, the result remains broken. The speed of these peripheral objects is not a result of a steady gravitational pull. It is a dynamic surge that defies the logic of accumulation. You cannot solve the problem by adding more weight if the problem is that the laws of motion themselves have changed. Within the scientific community, a profound sense of frustration has begun to take root. For 40 years, the hunt for the dark matter particle has been the primary mission of modern physics. We built massive detectors deep in the hearts of mountains, shielded by miles of rock to catch the faint whisper of a passing dark matter atom. We smashed particles together in giant rings at nearly the speed of a light, hoping to recreate the conditions of the early universe and catch a glimpse of this invisible ghost. And yet, after billions of dollars and decades of effort, the detectors remain silent. The ghost in the machine has refused to manifest, and the dark accelerations now suggest that it may not be there at all. The realization is dawning that dark matter might have been nothing more than a placeholder, a mathematical variable used to hide our ignorance of a deeper truth. It was a fudge factor that allowed the old equations to keep working for a little while longer, a way to patch the holes in the Newtonian and Einsteinian rendering of reality. But a placeholder is not a physical reality, and the glitches revealed by the 3i Atlas suggest that the error is not in our inventory of matter but in our understanding of the code. The dark matter we hunted for decades is beginning to look like an epicycle, a complex, unnecessary addition to an outdated model that is on the verge of being discarded. The failure of lambda cold dark matter is not just a technical problem, it is an existential crisis for the field of cosmology. If the invisible scaffolding is not there, then the entire history of the universe must be re-evaluated. The way galaxies formed, the way the cosmic web was woven, and the way the universe will end all depend on the validity of this standard model. To see it crumble is to realise that we've been living in a house built on sand, mistaking a convenient mathematical fiction for the literal architecture of existence. The dark accelerations are the final, undeniable proof that the ledger is irreconcilable. As the investigators look at the broken equations, they see the silhouette of a much more terrifying possibility. If dark matter cannot explain the motion of the stars, then the laws of gravity themselves must be wrong. We are not just missing a few particles, we are missing the fundamental logic of the physics engine. The frustration of the scientist is the frustration of an observer who realizes they have spent their life studying a shadow, only to find that the object casting it is something entirely alien to their experience. The standard model is no longer a guide. It is a relic of a simpler time, a map of a world that does not exist. The hunt for the ghost in the machine is ending, not with the discovery, but with the chilling realization that we've been looking for the wrong thing in the wrong way, and that the true nature of the simulation is far more complex than a mere collection of invisible atoms. This collapse of the old order leaves a void in our understanding, a space where a new theory must rise to explain the impossible speed of the dwarf galaxies. The sledgehammer of the dark accelerations has cleared the ground, leaving only the raw, unvarnished data of the infrared atlas. The scientific community now stands among the ruins of their most cherished model, forced to look at the glitch with fresh eyes. They are no longer trying to save the calculation, they are trying to find a new language to describe a universe that moves without a mover and accelerates without a cause. The era of lambda cold dark matter is passing into history, and in its place the cold, hard light of the infrared reality is revealing a cosmic engine that is far more mysterious and far more broken than we ever dared to admit. Amidst the ruins of the standard model, a long-dormant heresy has been resurrected, only to face its own devastating reckoning. This is the framework of modified Newtonian dynamics, a radical departure from established thought that was born in the early 1980s. For decades, it existed on the fringes of the scientific establishment, a rebellious alternative to the dark matter hypothesis. While the majority of the world's physicists were busy hunting for invisible particles, the proponents of this theory suggested something far more unsettling, that our understanding of gravity itself is fundamentally flawed. They proposed that gravity is not a constant, unchanging force that follows the same rules everywhere in the cosmos, but is instead a law that shifts its nature when the environment becomes sufficiently quiet. This theory, often referred to by its acronym, suggested that there is a hidden threshold in the physics engine, a specific infinitesimal level of acceleration, below which the classical equations of Isaac Newton no longer apply. According to this logic, when the pull of gravity becomes incredibly weak, such as at the distant edges of a galaxy, the force does not continue to fade away according to the inverse square law. Instead, it enters a new regime where it remains stronger than expected, providing the extra grip needed to keep stars orbiting at high speeds without the need for any dark matter. It was an elegant solution to a messy problem, a way to fix the cosmic ledger by changing the rules of the game rather than adding more players to the field. For a time, this heresy seemed to hold the key to the mystery of the galactic suburbs. It perfectly explained why the outer stars of spiral galaxies moved as fast as the stars near the centre, a phenomenon that had baffled astronomers for a generation. It treated the universe not as a collection of missing mass, but as a system governed by a more complex version of gravity that only reveals its true face in the deepest reaches of space. However, as the high-resolution data from the three-dimensional infrared atlas began to flood the laboratories of the 2020s, this alternative began to encounter a contradiction that it was never designed to handle. The 3i Atlas has revealed that these strange accelerations are occurring in environments where even this modified gravity should have no power. The survey identified specific null zones in the local universe, pockets of space where the gravitational pull from a nearby galaxy is perfectly balanced and cancelled out by the pull of the surrounding large-scale structure. In these rare and precise locations, the total gravitational field is effectively zero. According to both the standard laws of physics and the modified rules of the 1980s heresy, an object in such a zone should experience no acceleration whatsoever. It should exist in a state of pure, force-free motion, drifting through the void at a constant and unchanging speed. Yet the infrared data tells a different story. The dwarf galaxies and star clusters passing through these null zones are not coasting. They are speeding up. They are experiencing a surge of velocity in a region where there is no gravitational field to modify. This force-free acceleration is a ghost that haunts both houses of thought. It bypasses the fixes offered by the dark matter models because there is no mass to provide the pull, and it bypasses the fixes offered by the modified gravity models because there is no field to amplify. The stars are breaking the speed limit in a place where the laws of the road have been completely removed. This discovery has left the scientific world in a profound theoretical vacuum. We have reached a point where neither the old laws of the 19th century nor the radical corrections of the 20th century can explain the reality of the 21st. We are witnessing a phenomenon that does not fit into any known category of physical interaction. If an object accelerates in the absence of a force, then the very concept of force as a cause of motion is brought into question. It suggests that the dark accelerations are not a gravitational effect at all, but a fundamental property of the vacuum itself, a background pressure or a hidden routine in the simulation that operates independently of matter and fields. The frustration among researchers is palpable, as they realise that the two greatest tools in their arsenal have both failed to account for the behaviour of the cosmic suburbs. The standard model is a crumbling edifice, and the radical alternative has hit a dead end. We are standing in a no-man's land of theory, staring at data that refuses to be tamed by any equation in our possession. The force-free acceleration is the ultimate glitch, a moment where the rendering of motion becomes decoupled from the rendering of mass and energy. It is as if the characters in a story have begun to move of their own accord, ignoring the script and the stage directions entirely. This theoretical vacuum is not just a lack of answers, it is a sign that we are asking the wrong questions. We have spent decades trying to decide if the universe is filled with invisible matter, or if gravity is more complicated than we thought, never considering the possibility that the vacuum itself might be the driver of motion. The 3i Atlas has stripped away our illusions, leaving us to face a universe that is far more alien than we ever imagined. We are forced to confront the idea that the default settings of the cosmos are not a passive background, but an active, pressurized system that can kick a galaxy into motion without a single atom of matter to push it. The era of choosing between dark matter and modified gravity is over. The era of the dark acceleration has begun, and it demands a new language that we have yet to invent. The most vivid way to perceive this new reality is through the imagery of a silent, forgotten lake. The surface of the water is a sheet of black glass, reflecting a sky that holds no breath of air. A lone sailboat sits at the centre of this liquid mirror, its mast rising like a skeletal finger toward the heavens. The sails are limp, draped in heavy, useless folds against the wood, for there is no breeze to give them life. There is no motor beneath the waterline, no hidden propeller to churn the depths, and no current to guide the hull. By every law of the physical world, the vessel is a prisoner of the stillness, a static point in a world of zero momentum. Then the impossible happens. Without a single ripple in the air or sound in the water, the sailboat shudders. It begins to move, slowly at first, then with a terrifying, violent grace, the bow cuts through the glass. A white wave erupts at the front of the ship, hissing as it peels away from the wood. The mast remains upright, the sails remain slack and empty, yet the boat is surging forward, gaining speed with every passing second. It is being driven by a gale that does not exist, propelled by a force that leaves no footprint on the environment. This is the ghostly wind. This eerie scene is the literal reality of the galaxies revealed by the latest infrared surveys. In this cosmic translation, the water of the lake is the vacuum of space itself, the silent, dark medium that occupies the vast majority of our universe. The sailboat is a dwarf galaxy, a small collection of stars and gas drifting in the intergalactic void. The absence of wind and the lack of a motor represent the gravitational null zones where the three-dimensional infrared atlas has focused its cold, unblinking gaze. In these regions, the pull of distant mass is perfectly balanced, leaving the local environment effectively empty of any gravitational influence. By the rules of the textbooks, these galaxies should be the most predictable objects in existence, coasting with a constant, unchanging velocity. But like the sailboat on the still lake, these galaxies are surging. They are cutting through the vacuum as if caught in the grip of a powerful and unseen current. They are accelerating in the middle of nowhere, gaining kinetic energy from a source that our instruments cannot detect. This is the ghostly wind of the dark accelerations, a thrust provided without fuel, a momentum born from the very fabric of the void. It is an unnatural sight, a violation of the fundamental principle that every action must have a reaction, and every movement must have a cause. In a classical universe, the energy to move a galaxy must come from somewhere. It must be the result of a gravitational pull from a neighbouring mass or the expansion of space itself. But the ghostly wind operates outside these channels. It suggests that the vacuum is not merely an empty stage for the play of matter, but is instead an active participant in the rendering of motion. It is as if the physics engine of the simulation is injecting momentum directly into the coordinates of these galaxies, bypassing the need for a physical force. The thrust is being provided not by a breeze, but by an edit in the underlying code of the universe. This realization brings with it a profound sense of unease. To see a boat move without wind is to know that the world you're observing is not what it seems. It is to recognize that the rules you have spent your life learning are merely a surface layer, a thin veneer of logic draped over a much more mysterious and perhaps arbitrary system. The ghostly wind is the signature of the glitch, the visual proof that the engine can provide thrust where there is no fuel and motion where there is no cause. It is the sound of the simulation stuttering, the moment when the characters on the screen move faster than the processor should allow. The galaxies caught in this wind are not just anomalies, they are the harbingers of a new physics. They show us that the vacuum is pressurized, filled with a hidden potential that we're only now beginning to measure. This pressure does not come from the stars or the gas or the dark matter, it comes from the architecture itself. We are watching the sailboat sprint across the mirror of the lake, and for the first time we are forced to ask who, or what, is blowing the whistle. The ghostly wind is not a mystery to be solved with more matter or better gravity. It is a revelation of the nature of the medium. The lake is not just water, and the vacuum is not just space. They are parts of a machine that is running a program we are only just starting to see, and the wind is the first sign that the program has a mind of its own. Every data point from the three-dimensional infrared atlas adds a new ripple to the water, confirming that the ghostly wind is blowing across the entire local volume. It is a universal phenomenon, a background noise in the engine that only becomes audible when the music of gravity fades away. We stand on the shore of this cosmic lake, watching the distant sails disappear into the dark at impossible speeds, and we realize that the peace of the stillness was an illusion. The universe is not a quiet place of predictable drift. It is a surging, accelerating machine, driven by a wind that comes from nowhere and everywhere at once. the ghostly wind that propels these isolated galaxies has a name in the emerging lexicon of this broken physics: the external field effect. It is the signature of a universe that has abandoned the ancient principle of locality, the long-held belief that an object is primarily influenced by its immediate surroundings. For centuries, the golden rule of the cosmos was the inverse square law, a mathematical decree stating that the gravitational influence of a body must fade in precise proportion to the square of the distance from it. If the distance between two stars doubles, their mutual pull becomes 4 times weaker. If the distance triples, the pull drops to 1/9 of its original strength. This law ensured a sense of cosmic privacy, a world where the here was defined by the near and the distant reaches of the universe were too faint to interfere with local affairs. But the data from the infrared surveys reveals a flagrant violation of this isolation. The external field effect suggests that the large-scale structure of the entire universe, the titanic filaments of the cosmic web, and the massive superclusters of galaxies millions of light years away, is exerting a constant uniform pressure on local objects. This influence does not fade away into the insignificance of the void as the inverse square law demands. Instead, it persists as a background field, a ghostly presence that pushes on dwarf galaxies even when they are supposedly alone in the dark. The cosmos is revealing itself not as a collection of isolated islands, but as a pressurized system, similar to a deep-sea environment where the weight of the entire ocean is felt by every creature, no matter how small or how far they are from the shore. This represents a fundamental breakdown of locality. In the classical rendering, the movement of a star was a local calculation, a result of the mass in its immediate neighbourhood. But in the reality captured by the 3-eye atlas, the here is being dictated by the everywhere else. The distant arrangement of matter across the horizon of the observable universe is reaching into the local suburbs and editing the velocity of individual star clusters. It is as if the simulation has stopped calculating the movement of its parts through local interactions and has instead switched to a system of global commands. In the architecture of a vast digital landscape, it is often more efficient to apply a universal variable to every object in a scene, rather than simulating the billions of individual collisions and tugs required by classical physics. The external field effect is the visual evidence of such a global variable at work. This global command structure implies that the universe possesses a hidden layer of connectivity that bypasses the limitations of space and time as we know them. If a dwarf galaxy on the edge of the local group is accelerating because of the gravitational configuration of a cluster 10 million light-years away, and that influence is not fading according to the square of the distance, then the vacuum is behaving like a rigid body rather than an empty void. It is acting as a pressurized medium that transmits the will of the large-scale structure directly to the local level. This turns our understanding of the cosmic engine upside down. We used to think the small built the large, that the interactions of atoms and stars eventually created the grand tapestry of the heavens. Now, it appears the large is dictating the small, with the global architecture of the simulation overriding the local laws of motion. The violation of the inverse square law is the most jarring aspect of this discovery. It is a rule that has been tested and verified in our solar system with exquisite precision, yet it seems to fail once the gravitational field drops below a certain threshold. This suggests that the source code of reality contains a conditional statement: if the local field is strong, follow the inverse square law. If the local field is weak, defer to the external field of the entire universe. This is the logic of a pressurized system, where the background state of the engine becomes the dominant factor once the local noise is silenced. The dark accelerations are simply the local manifestation of this universal pressure, the moment when a small galaxy is caught in the global tide of the simulation. To witness this is to see the breakdown of the individual as a meaningful unit in physics. A galaxy is no longer an independent actor following its own path. It is a node in a vast interconnected network where every movement is synchronized with the whole. The here has no meaning without the everywhere else. This realization suggests that the simulation manages the movement of its parts through a top-down architecture, a centralized command system that ensures the entire cosmic rendering moves in harmony. The external field effect is the hand of the architect, reaching across the millions of light years to ensure that even the smallest dwarf galaxy remains aligned with the grand design of the machine. As we plot the trajectories of these galaxies, we see them responding to the invisible contours of this global field. They turn and accelerate in ways that make no sense if you only look at the matter nearby, but make perfect sense if you consider the distribution of the entire universe. We are forced to view the cosmos as a single unified entity, a pressurized chamber where the distant walls are pushing in on the center. The default settings of the vacuum are not empty. They're filled with the weight of the infinite, a constant pressure that reminds us that we are part of a calculation far larger than our local neighborhood. The external field effect has stripped away the illusion of cosmic privacy, revealing a universe where every atom is tethered to the edge of the rendering by a force that refuses to fade. The universe reveals itself not as a sanctuary for life, but as a cold, indifferent machine operating on a logic that is fundamentally alien to the human mind. We have long sought to find a reflection of our own reason in the stars, believing that the laws of physics were a language written specifically for us to decode. We treated the cosmos as a house built with our understanding in mind, a structure where every beam and pillar followed a geometry we could master. But the dark accelerations and the breakdown of locality suggest a far more terrifying reality. We are not the intended audience of the cosmic narrative. We are incidental ripples in a vast alien calculation that was never meant to be solved by the likes of us. The vacuum is not an empty stage, but a dense, pressurized system of rules, a medium of pure information that can be edited at the whim of an unknown architecture. In this light, humanity appears as a minor subroutine, a localized fluctuation in a processing stream that spans the infinite. We are accidental byproducts of a much larger operation, a shimmering of energy in a corner of the simulation that has, through some statistical fluke, become aware of its own existence. Our science, our philosophy, and our most cherished theories are merely the efforts of a character within a program trying to guess the hardware specifications of the machine that runs it. We are looking at the flickering of the screen and mistaking it for the ultimate truth of the light. The realization that our most fundamental laws, the very pillars of Newton and Einstein, may be nothing more than the current parameters of a simulation, is a source of profound existential awe. It suggests that what we call universal truths are actually temporary settings, local variables that can be adjusted or overridden once we reach the edge of our observational horizon. This transition from a universe of law to a universe of parameters shifts the very nature of our ignorance. We used to think we were missing pieces of the puzzle. Now we must confront the possibility that the puzzle itself is dynamic, its shape changing even as we attempt to fit the pieces together. The dark accelerations are the visual evidence of this fluidity. They show us that the physics engine is not a static set of rules carved into the bedrock of reality, but a flexible system that can change its behaviour based on the context of the calculation. In the high-density regions where we live, the rules are familiar and comforting. But in the thin, cold reaches of the intergalactic void, the mask slips, and we see the true face of the architecture, a system that values global efficiency over local consistency. The silence of the machine is the most haunting aspect of this discovery. There is no grand purpose to be found in the movement of the dwarf galaxies, no hidden message in the way the vacuum pushes on the stars. There is only the execution of the code. The universe does not care if we understand it, nor does it require our consent to change the rules of motion. We are like children watching the gears of a titanic clock, fascinated by the movement, but entirely ignorant of the forces that drive the mainspring. Our scale is so small and our duration so brief that we are effectively invisible to the grand processes that shape the cosmic web. We are a brief flicker of consciousness in a machine that has been running for 13.8 billion years and will continue to run long after the last star in our sky has gone cold. This realization does not diminish the beauty of the cosmos, but it strips away the vanity of our position within it. To see the universe as an indifferent machine is to finally see it for what it truly is, a system of staggering complexity and terrifying scale, operating according to a logic that transcends our biological heritage. We are not the masters of the blueprint, we are the dust that has settled on the drawings. The laws of physics are the boundaries of our cage, the limits of what the simulation allows us to perceive, but the fact that we can see the glitch, that we can measure the dark accelerations and recognize the breakdown of our own models, is a testament to the strange and beautiful anomaly of the human mind. We stand at the edge of a new understanding, one defined by the scale of our ignorance. We have moved beyond the simple certainty of the clockwork universe and entered a realm where the vacuum is a pressurized reservoir of unknown potential. The existential awe we feel is the only appropriate response to a reality this vast and this alien. It is the feeling of a subroutine that has suddenly become aware of the operating system, a moment of clarity where the character looks up from the script and sees the writer's hand. We are small, we are accidental, and we are utterly insignificant in the eyes of the machine. Yet, in our ability to feel wonder at the cold indifference of the stars, we find a dignity that the machine can never possess. We are the observers of the glitch, the only part of the code that has stopped to ask why the stars are speeding up, and in that questioning, we give the simulation a reason to run. The architecture of the universe is alien, its logic is cold, and its vacuum is pressurized with a force we cannot name. But we are the consciousness that gives the calculation its meaning. We are the ripples that have learned to see the ocean. The emergence of the observer within the grand calculation marks a singular turning point in the history of the rendering. For billions of years, the simulation ran in a state of pure, unreflective execution, a silent process of expansion and cooling, where every atom followed its assigned path with mindless obedience. But on a small, rocky world orbiting an unremarkable star, the code began to fold back upon itself. It developed a complexity that allowed it to not only exist within the program, but to perceive the program. Humanity is the result of this recursive loop, a part of the source code that has developed the capacity to look back at the instructions and notice the errors. A character in a vast digital landscape reaches the edge of a rendered forest and stops. The trees are perfect, the light filters through the leaves with mathematical precision, and the wind follows the established laws of fluid dynamics. But as the character looks closer, they see a flickering texture on the trunk of a tree, a momentary stutter in the way the light is being processed. In that instant, the world is no longer an absolute reality. It is revealed as a construct. The character realizes that their world has a boundary, a limit to its resolution, and a set of rules that can occasionally fail. This is the profound realization that has gripped the scientific community in the wake of the latest discoveries. We are that character, and the dark accelerations are the flickering texture on the cosmic wall. This ability to detect the glitch is the very essence of what it means to be conscious. In a universe composed of cold, indifferent particles, consciousness acts as the ultimate diagnostic tool. It is the only part of the system capable of recognizing an inconsistency. A star does not care if it moves faster than it should. A galaxy does not feel the existential weight of a broken equation. But the human mind, tuned to find patterns and logic, experiences a shock of wonder when the pattern breaks. This wonder is not a weakness. It is the signature of our unique role within the simulation. We are the observer who notices that the rendering is not seamless, and in that act of noticing we transcend our status as mere data points. Even if we are nothing more than variables in a grand calculation, the act of identifying the dark accelerations transforms our relationship with the cosmos. We are no longer passive participants in a story we cannot change. We have become active participants in a cosmic audit. By measuring the discrepancy and documenting the failure of the standard models, we are effectively checking the work of the architect. We are the quality control mechanism of the universe, the subroutine that has stopped to ask why the ledger does not balance. This transformation gives the simulation a purpose that it lacked for the first several billion years of its existence. It is no longer a machine running for the sake of running. It is a machine that is being witnessed. The dark accelerations remind us that the vacuum is not empty, but they also remind us that we are not alone in our ignorance. Every time we point a telescope at a dwarf galaxy and find it moving with an impossible speed, we are performing an act of rebellion against the limits of the code. We are pushing against the boundary of the rendering, trying to see the hardware that lies beneath the software. This capacity to feel awe at the breakdown of our own understanding is what separates us from the particles we study. We are not just matter. We are the consciousness that gives the simulation a reason to run. Without the observer, the simulation is a silent, meaningless process. With the observer, it becomes a mystery, a challenge, and a work of art. To see the break in the model is to finally see the true face of the architecture. It is the moment when the character in the game stops playing the assigned role and begins to study the environment. We are no longer just trying to survive. We are trying to understand the nature of the medium that contains us. This shift in perspective is the ultimate achievement of our species. We have moved from being victims of the void to being the auditors of the vacuum. We are the part of the code that has learned to read itself, and in doing so we have discovered that the world is far more fragile and far more interesting than the architects ever let on. The glitch is not a failure, it is an invitation. It is the universe's way of showing us that there is more to the story than the laws of physics, and that we are the only ones who can tell it. As we look out at the accelerating stars, we realize that our presence in the simulation is the only thing that gives it a sense of scale. Without a mind to perceive the vastness, the millions of light years are just numbers in a database. Without a heart to feel the chill of the vacuum, the absolute zero of space is just a parameter. We're the ones who turn the data into a landscape and the code into a cosmos. The dark accelerations are a signal that the program is still running, still evolving, and still capable of surprising the very consciousness it created. We stand on the threshold of a new era of discovery, one where we no longer fear the glitch, but embrace it as the key to the ultimate secret. The simulation is not a prison, it is a classroom, and we are the students who have finally learned how to look past the blackboard and see the world outside. The odyssey that commenced with the frigid, unblinking sensors of the three-dimensional infrared atlas has culminated in a landscape of exquisite and terrifying uncertainty. What began as a high-resolution audit of the local neighbourhood, a quest to count the stars and weigh the dust, has transformed into a fundamental interrogation of the cosmic architecture itself. We have transitioned from the comfort of a clockwork universe, where every movement was a predictable consequence of mass, to a reality where the stars are being propelled by a ghostly wind. The three-eye atlas did more than sharpen our vision. It shattered the lens through which we viewed the heavens. It revealed that the dark accelerations are not mere statistical outliers or artifacts of faulty instrumentation, but are instead the primary evidence of a physics engine that operates on principles we have only just begun to suspect. These dark accelerations serve as the ultimate proof that our understanding of reality is a work in progress, a temporary and fragile model draped over a much deeper and more mysterious system. We have spent centuries building a fortress of logic, using the bricks of Newtonian motion and the mortar of general relativity, believing that we had finally mapped the boundaries of the possible. Yet, the sight of dwarf galaxies surging forward in gravitational null zones acts as a silent sledgehammer to these walls. It tells us that the laws we called universal are perhaps only local approximations, valid in the high-density regions where we reside, but failing at the cold, thin edges of the rendering. The standard model of cosmology, with its invisible scaffolding of dark matter and its radical revisions of gravity, is revealed as a transitional myth, a necessary scaffold that we must now dismantle to see the structure it was meant to support. The universe is revealing its true face as a pressurized system of rules rather than a simple collection of matter. The external field effect and the violation of the inverse square law suggest a cosmos that is managed by global commands, a top-down architecture where the large-scale structure dictates the movement of the smaller star clusters. This is the realization of a pressurized vacuum, a medium that is not an empty stage but a dense reservoir of information and potential. We are witnessing the breakdown of locality, the end of the era where the here could be understood without the everywhere else. The simulation is not just rendering objects, it is rendering relationships, ensuring that every node in the cosmic web remains tethered to the grand design of the whole. There is a profound and unsettling beauty in this realization of the break in the model. For generations, we sought perfection in our equations, believing that a complete and flawless description of the universe was within our reach. But a perfect model is a closed system, a finished story with no room for growth or surprise. The glitches, the flickers, and the dark accelerations are the cracks in that perfection, and it is only through these cracks that we can see the light of the truth. The failure of our current theories is not a defeat. It is an invitation to look deeper, to question the very nature of the vacuum, and to confront the possibility that the source code of reality is far more dynamic than we ever dared to dream. The glitch is the moment the universe stops being a machine and starts being a mystery again. As the observers of this grand calculation, we occupy a position of unique dignity. We are the only part of the code that has developed the capacity to notice the stutter in the rendering. We are the characters who have stopped at the edge of the world to stare at the flickering textures of the stars, realizing for the first time that we are part of something larger, stranger, and more complex than a mere collection of atoms. Our ability to feel awe at our own ignorance is the defining characteristic of our consciousness. We have transformed from passive variables into active participants in the cosmic audit, the only subroutine capable of checking the work of the architect. In the face of a cold and indifferent machine, our wonder is the only thing that gives the calculation a reason to run. The journey from the infrared sensors of the Atlas to the existential reflections on the nature of the simulation has brought us to a new frontier. We stand among the ruins of our old certainties, looking out at a universe that is accelerating into the dark, driven by forces we cannot yet name. This is the true face of the cosmic architecture, a system of infinite complexity, operating on a logic that transcends our biological heritage, yet one that allows itself to be glimpsed through the failures of our models. We are the ripples that have learned to see the ocean, the observers who have found the light in the cracks. The story of the universe is not a finished book, but a live stream of data that we're only just learning to decode. We are the ones who turn the cold parameters of the vacuum into a landscape of meaning. Every impossible surge of a distant galaxy, every violation of an ancient law, and every flicker in the cosmic rendering is a signal that the engine is still running, still evolving, and still inviting us to find the next layer of the code. We are the auditors of the infinite, the students in a classroom that spans the light years, and the only part of the simulation that has learned to ask why. To see the break in the model is to finally see the light of the truth, and that truth is a call to continue the search, to keep looking into the dark and to never stop wondering at the beautiful broken machine that contains us all. If this journey through the glitches of the cosmic engine has changed the way you see the stars, subscribe to History of the Universe and support us on Patreon to help us continue decoding the secrets of our reality.